In this video, we're going to look at variables and solving equations with variables. Variables are letters or symbols that represent numerical quantities. For example, in the area formula for a square, a equals s squared. A is a variable and it represents the area. S is a variable that represents the side length of the square. In algebra, the variable x is often used to represent an unknown quantity. Also, y, z, and t are often used along with other variables. An equation consists of equating two numerical or algebraic expressions with an equal sign, and usually an equation has variables in it. Here's some examples of equations. X plus 4 equals 18. Here, x is an unknown quantity that when we add 4 to it, we get 18. Another example of an equation is 3x equals 12. Here, an unknown quantity x is multiplied by 3, and the result is 12. Now note that when you have a number next to a variable, 3 next to x, that implies that 3 is multiplied by x, even though there's not a multiply sign in between. Just remember that. In the last example, we have 4x plus 1 equals 10. Here, this represents the equation where 4 is multiplied by some unknown x, and then 1 is added to that result, and that result is then equal to 10. Again, 4 next to x means 4 times x. In the next examples, we're going to look at how to solve these equations. We're going to look at the two different methods of solving equations. First, we have to define solving an equation. That means to find the value of x or values of x that make the equation true. So that means when you plug in that value of x, you get a true statement. The two methods we're going to look at are the first being by inspection, which really amounts to guessing an answer and then checking to see if it results in a true equation. And the second method is using algebraic properties of equality. And that's really what this course is more about. In this first example, we're going to solve the equation x plus 4 equals 18 by both inspection and also by using algebraic properties of equality. By inspection, we simply ask ourselves, what number do we add to 4 to get 18? Well, I think most of us would come up with the answer 14 pretty quickly. So x equals 14 is our guess. And then if we plug in x equals 14 into the equation, we get 14 plus 4 equals 18. And that verifies that it is a solution. So x equals 14 is our solution. Using algebraic properties to solve this, we would subtract 4 from both sides to get x all by itself. And when we do that, we end up getting x plus 0 equal 18 minus 4, which is 14. And x plus 0 just turns into x, so we get our answer x equals 14, which is the solution we verified earlier. In this example, we use the subtraction property of equality to subtract 4 from both sides. And then we replaced x plus 0 with just x, and that really uses the zero property of addition, which says any variable or number added to 0 is just the variable or the number. Now this seems kind of silly to solve this algebraically when the answer is obviously 14, but when we get to the third example, you'll see why the algebraic method is absolutely needed. In this second example, we're going to solve the equation 3x equals 12 by both inspection and by using algebraic properties of equality. By inspection, we think to ourselves, 3 times what number is 12? Well, the answer is pretty easy. It's x equals 4. So to verify that, we plug in 4 and we get 3 times 4 equals 12, a true statement. So x equals 4 is indeed our solution. By using algebraic properties, we can take both sides of this equation and divide by 3. What's going to happen then is the 3's will cancel, leaving just x on one side. So we divide both sides by 3. And when we divide by 3 on both sides, the 3's cancel on the left. And also the 12 divided by 3 gives us 4 over 1, or just 4 on the right. So the result is 1x equals 4. And that just simplifies to x equals 4. In this example, we use the division property of equality to divide both sides by 3. And we use the multiplication property to rewrite 1x as just x, because the multiplication property of 1 assures us that 1 times x or any variable just equals x or that variable. In this final example, we're going to solve the equation 4x plus 1 equals 10 by inspection and also using algebraic properties of equality. Well, to solve by inspection, we ask ourselves, what number would you multiply by 4 and then add 1 to give us 10? Well, that answer is not so obvious. In fact, the answer will be a fraction, and really the only way we can get that answer is by performing the algebraic operations needed in our head. So let's jump right to the algebraic properties method. To solve algebraically, we would first subtract 1 from both sides of the equation. And when you do that, the 1 minus 1 gives you 0, the 10 minus 1 gives you 9, and you get the equation 4x plus 0 equals 9. But by the 0 property of addition, we can just rewrite this as 4x equal 9. Now we're almost done. We divide both sides by 4 like we did in the previous problem to cancel out the factor. And the 4x divided by 4 just gives us x. And the 9 divided by 4 is just 9/4. Actually, we get 1x equals 9/4, and then the 1x can be written as x. So we have x equals 9/4. So here we perform the two algebraic operations we did in the two previous examples, and this gave us our solution. If we plug 9/4 back in, and we take 4 times 9/4, and if you notice I did something a little sneaky here, I snuck in that multiply sign. And I really don't need the multiply sign. When you have a number next to another number in parentheses, that automatically implies multiplication. But I put in the multiply sign just to clarify this. We have 4 times 9/4. What happens is the 4's cancel, leaving 9 plus 1 equals 10. And if you're having some difficulties with these fractions, we're going to have a whole unit on fractions later on. So 9/4 is our solution. We use the subtraction property of equality, the division property of equality, and we also use the 0 property of addition and the multiplication property of 1. We used all those algebraic properties that we used in the previous examples. And you can see why they're important as the equations become more and more complicated.